Hello and welcome to the video for section 7.5. There will be two videos for this section. This is the first of those two videos. Section 7.4 was trig equations. Section 7.5 is more trig equations. So in 7.4, we started with the straightforward ones. You just had like sine of theta is equal to a half and you solve for theta. We ended with the factoring ones, so we were able to factor out a common piece usually. In 7.5, we're going to look at ones that aren't quite so straightforward. We need to do some manipulation with the equation to get it to an equation we can factor, or that we can solve. So let's look at an example like that. So let's say we want to figure out the following. We want to solve 1 plus sine of theta is equal to 2 times cosine squared of theta. So, in this situation, there's nothing, if we move this over, we can't factor out a sine or we can't factor out a cosine like we did before. So what we're going to need to do is use our trig identities. Specifically, the one we'll be using a lot is the Pythagorean identity. That's why I told you guys it's like the holy grail of our identities. If we ever get stuck on a problem, be it simplifying, proofs, solving equations, if you get stuck like, boy, I just don't even know what I'm supposed to do here, think to yourself, okay, can I use those Pythagorean identities? And the answer is yes for this case, because let's look at this piece. Cosine squared of theta is equal to what? Well, that's 1 minus sine squared of theta if we move our Pythagorean identity around. Remember, we had sine squared plus cosine squared is 1. So if we take the sine squared over, it gives us this. So if I use substitution and plug this guy in for the cosine squared of theta, what do I get? I get an entire equation that's nothing but our sine function. And then we can actually work it from there. So let's do that. Let's substitute that in. So we get 1 plus sine of theta is 2 times this guy. 1 minus sine squared of theta. So now we just need to distribute, move everything to one side so that we can factor and use zero property rule. So we get what? We get 1 plus sine of theta is 2 times 1 is 2. 2 times negative sine of theta is minus 2 sine squared of theta. So now if we want to move this over, I need to subtract 2 from both sides, and I need to add 2 sine squared of theta to both sides. So when I do that, I end up with 2 sine squared of theta plus sine of theta, and then 1 minus 2 is minus 1. And don't forget this all equals 0 because we moved everything from the right over to the left. So the only thing left on the right side is 0. So now I can factor this portion here. Oh, and we want to solve this in the interval 0 to 2 pi. So we just want the distinct solutions one time around the unit circle. So if we do that, if we factor this portion, what do we get? We get 2 sine of theta minus 1 and sine of theta plus 1. And again, you can check, just FOIL it. 2 sine of theta times sine of theta is 2 sine squared. 2 minus 1 is 1. And then negative 1 times positive 1 is negative 1. So now if we solve each of these separately, we have 2 sine of theta minus 1 is 0 using zero property rule, and sine of theta plus 1 equals 0. So move the 1 over, we get 2 sine of theta equals 1. So sine of theta is 1/2, and we've seen this a few times already. That means theta is pi over 6, or 5 pi over 6. So there's 2 possible answers. And then over here, if we subtract 1 from both sides, we get sine of theta is minus 1. And where is sine of theta equal to negative 1? Well, that's at when theta is 3 pi over 2. That's the only place on the unit circle sine of theta is minus 1. So even though we got two solutions here, we only have one for this one. So these would be our answers in the intervals 0 to 2 pi. So one time around the unit circle, these three values, if we plug it into our original equation, would make this true. So that's it. That's an example of one that's a little more difficult than our sort of straightforward examples. All right, I'm going to erase this. We'll work another example. Pause it if you need to, and come on back. Okay, so this next example, we want to solve cosine theta plus 1 equals sine of theta in the interval 0 to 2 pi, so just one time around the unit circle. What are the values there? So this one, we have cosine theta plus 1 is equal to sine of theta. So there's nothing that just by moving pieces around we could factor. We can't use zero property rule if we just subtract the sine of theta. So what did I say? If we get stuck, what's our go-to? It's our Pythagorean identities, specifically the basic one, cosine squared plus sine squared equals 1. I don't have any squareds here, so what can I do? Well, what I can do then, or what I'm going to do, is I'm going to square both sides. I can do that because think of the example if I have 2 is equal to 2. That's true. So if I square both sides, what do I get? 4 equals 4. But if you remember back to 126, or to maybe your high school algebra if you came right from high school, whenever we square both sides, what do we have to do? We have to check our final answer, because this squaring can possibly create some problems for us. What am I talking about? Well, if I have negative 2 equals 2, that's not true, obviously. But what if I square it? If I square it, I get 4 is equal to 4. And that is true. So once I square it, I could get an answer that is true, but is not true for the original case. So I'm going to square this equation in order to solve it. But once I solve it, because I did that squaring process, whatever answers I get at the end, I have to go back to the original equation and check my answers to make sure that it is in fact legitimate answers. So if I square this, don't forget, I'm not just doing cosine squared and 1. This is like cosine of theta plus 1, cosine of theta plus 1. So make sure you FOIL this thing, or FOIL it in your head to make sure you get the right answer. Otherwise, you're going to be missing a term. So if we do this, we get cosine squared of theta plus 2 cosine of theta plus 1 is equal to, now this one doesn't have a plus or minus inside, so it's just going to be sine squared of theta. So now this is similar to the first example we looked at in this video. We have some cosine squareds, we have sine squared. What do we want to do? We want to get just one trig function. So this guy is equal to what? This is 1 minus cosine squared. So if I substitute that in, I get cosine squared theta plus 2 cosine theta plus 1 is equal to 1 minus cosine squared theta. So now again, I want to move everything to one side, 0 on the other. So I'm going to subtract 1 and add cosine squared of theta. So I get minus 1, add cosine squared theta. So what do I end up with? Well, on the right, I end up with 0. That's what I want, so that I can use zero property rule. Cosine squared plus cosine squared is 2 cosine squared of theta, and then plus 2 cosine of theta. So now I have an equation with just cosines equal to 0, so I can factor use zero property rule. So I'm going to let you guys try to work this one, so go ahead and hit pause. Try to work your solution to get theta, and then don't forget you need to check them in the original equation to see if they actually work. Once you go through that process, go ahead and hit play. I'll work it through. We'll see if we end up with the same answer, or if you had any troubles, you'll see where maybe you got caught up. Okay, hopefully you got some answers to work. So what do we have to do here? What can we factor out? Well, we can factor out a 2 cosine theta out of each piece. When I do that, what do I end up with? I end up with cosine of theta from the first term, and if I take 2 cosine theta out of the second term, I just have 1 left over. So now I have 2 terms. Multiplied together, I use zero property rule. So 2 cosine of theta is equal to 0, and cosine of theta plus 1 equals 0. Divide by 2 in the first one, I get cosine of theta is 0. And where is cosine of theta equal to 0? Well, it's when theta is equal to pi over 2 and 3 pi over 2. In the second equation, if I subtract 1 from both sides, I get cosine of theta is minus 1. And where is cosine of theta equal to minus 1? Well, that's when theta is equal to pi. So I have 3 possible answers, but I need to go in and check all these into the original equation before I squared it. So let's first check our pi over 2. So if I plug in pi over 2 for theta, so think of this when we had the problems where we solved for x. X equals something, and we plug it into the original equation for x. So for pi over 2, if I plug it in, I get cosine of pi over 2 plus 1. Does this equal sine of pi over 2? Well, cosine of pi over 2 is 0. Sine of pi over 2 is 1. 1 does equal 1, so we know that at least pi over 2 is a possible solution. Let's check 3 pi over 2. So if we plug that in, we get cosine of 3 pi over 2 plus 1 is equal to, is it in fact equal to, sine of 3 pi over 2. So cosine of 3 pi over 2 is 0 plus 1. Sine of 3 pi over 2 is negative 1. 1 is not equal to negative 1. So that means 3 pi over 2 is not a solution to the original equation. And this is where that squaring came in. 1 is not negative 1, but if I square both these sides, positive 1 is equal to positive 1. So that's the catch, that's the trick we have to watch out for. And lastly, let's check pi. So I have cosine of pi plus 1 is equal to sine of pi. Well, cosine of pi is negative 1. Sine of pi is 0. 0 does equal 0, so that means pi is also a solution. So the two solutions to this original equation is theta equals pi, or theta equals pi over 2, or theta is equal to pi. So that's it for the first video. 2 examples a little more complicated than what we dealt with in the original. Come on back and we'll look at some other type of trig equations we might encounter.